Hi students, welcome to physics classes. Today we'll discuss ray diagrams for convex lens, biconvex lens. Ray diagrams for biconvex lens. We have discussed already about rules to draw ray diagrams. Rules to draw ray diagrams. When an object is placed at different positions in front of the biconvex lens, by using these rules we can draw ray diagrams. What is first rule? If a ray passing parallel to the principal axis, after refraction it passes through focus. If it is passing through focus, after refraction it passes parallel to the principal axis. If it is passing through optic center, after refraction it travels without any deviation. If it is passing through center of curvature or 2f2, after refraction it passes without any deviation. Based on these rules, we will draw ray diagrams. Now here, in front of the lens, we have f2, 2f2 names. Based on these, we can place object at different positions. First, we can place between optic center and focus f2, and then we can place at f2, and then we can place between f2 and 2f2, and then we can place at 2f2, and we can place beyond 2f2 and at infinity. These many locations we can place the object. First we will see object is placed at between optic center and f2. Object is at between optic center and f2. O means optic center, f2 focus. Now this is the biconvex lens. Principal axis, optic center, f2, 2f2, f1, 2f1. Now an object is placed between optic center and f2. Here I am placing. Now we can take two rays, and we have discussed light ray should start from the object. Light rays should start from the object, and after refraction, where they will meet, their image is formed. Now if you see here, I am taking one ray parallel to the principal axis, another one ray passing through optic center. Now the ray which is parallel to the principal axis, after refraction it passes through focus. Now second ray, the ray which is passing through optic center, after refraction it passes without any deviation. Now I told you, after refraction, where the rays will meet, there will be the image. Now if you see, these two rays are not meeting anywhere. If you see, these are as going away, gap between them is increasing. So we can say these are diverging rays. What are these? Diverging rays. What is meant by diverging rays? beam of rays traveling different direction from one point to different directions is known as diverging rays. One point to different, so you extend back, it will meet at one point. If you extend like this in a forward direction, if these rays are not meeting any point, we can extend them back like this. This one also we can extend back. It should be straight. Action should be straight. Now these are meeting at this point, extending back and meeting at this point. So here image will be formed. Here is the image. When an object is placed between optic center and focus, image is formed beyond object, and its size of the image is magnified or enlarged. Means more than the size of object. Magnified or enlarged means more than the size of object. Nature of the image, it is extending the refracted rays. It is meeting at a point after extending the refracted rays. These are known as virtual image. And image is upright, head is forming correctly. As object is upward arrow, image also upwards. So this is upright image. It is known as erect. Okay. Object is placed between optic center and focus. Image formed beyond the object. Size magnified or enlarged. Nature is virtual and erect. Now object is placed at focus f2 in front of the convex lens. This is the convex lens, principal axis, optic center f2, 2f2, f1, 2f1. Now the object is placed at f2, means at the focus. Now we will take two rays. One is passing parallel to the principal axis. The ray which is passing parallel to the principal axis, after refraction, it passes through focus. Another ray I am taking passing through optic center. The ray which is passing through optic center will travel without any deviation. Now these two rays appears passing parallel to each other. These two rays are parallel to each other. These are two parallel rays. Now whenever rays are diverging, they are moving away from each other. So what we did, we extended back. They are meeting at one point. Now here they are parallel. Parallel rays, if you extend forward, they won't meet. If you extend backward, they won't meet. So these two are not meeting at any point. So we can consider they will meet at infinity. Infinity means somewhere. We'll consider they will meet at infinity. So image formed at infinity. Image formed at infinity. Okay. Thank you for watching. Please subscribe. Now object is placed between f2 and 2f2 in front of biconvex lens. Biconvex lens. Principal axis f2, 2f2, f1, 2f1. Now object is placed between f2 and 2f2. f2 and 2f2. We will take two rays. One is passing parallel to the principal axis. The ray which is passing parallel to the principal axis after refraction passes through focus. Passes through focus. Now another ray I am taking passing through optic center. The ray which is passing through optic center travel without any deviation. Here both are meeting, so image is formed here. That is the image. That is the image. Object is placed between f2 and 2f2. Image is formed beyond 2f1. Object is placed between f2 and 2f2. Image is formed beyond 2f1. Now we will see the characteristics of the image. Now object is placed between f2 and 2f2. So image is formed beyond 2f1 and size, see, magnified more than the size of object, magnified or enlarged, magnified or enlarged, as rays are directly meeting real inverted, real and inverted. Application. What is the application where we are using? For smaller object, image is real and magnified, real and magnified. So it is used in projector screen, projector lens, used in projectors. Okay. Now the object is placed beyond 2f2. Now we will take again biconvex lens, principal axis, optic center, f2, 2f2. Here is the object. Now we will take two rays. One is passing parallel to the principal axis. The ray which is passing parallel to the principal axis passes, after refraction, passes through focus. So it is passing through focus. Now another ray I am taking that is passes through optic center. The ray which is passing through optic center, after refraction it travels without any deviation. So here image is formed. This is 2f1. Now characteristics of the image. characteristics of the. Now the image is formed between f1 and 2f1 and the size diminished. Nature real and inverted. Application camera lens, photographic lens. For tall object will get small image. Okay.